Question number 4 deals with what? Work done in isothermal process. What is an isothermal process? Process in which temperature remains constant. So, for a PV graph, here you have a piston. Initial status of the piston, gas is having some pressure P1, some volume V1. So this is point number 1. Pressure is P1, volume is V1 and temperature is T. As the gas expands, it will attain a final volume V2. Final volume is V2, and the process is, as discussed in the previous question, isothermal process. Process starts from 1, ends up at 2. At this point, the pressure is P2, volume is V2 and temperature is T. Temperature remains a constant. Notes band kar do. One full page. Draw the diagram. Draw the diagram. Chapter number 4. Small amount of work done, dW, is equal to Fdx. And the total work done was area under Fx graph. But in thermodynamics, you will deal with not force but pressure. Pressure of the gas. That is why we divide and multiply by A. Force per unit area is pressure. Area into dx. This is area if it moves small distance dx. Let this is volume V. It covers small distance dx. This is small distance covered dx. This is small volume is how much? Area into dx. And on the diagram, this is pressure P, this is small volume dV. Small amount of work done is area into distance is volume, it is P dV. This is step number 1. 2. Total work done, integrate both sides. If you integrate both sides, dW is equal to P dV. Work done is equal to integration of, now P and V, we need to check whether one parameter is constant or not. As you move along this path, pressure decreases, changes, volume also changes. So during the process, both P and V are variables. If P and V are variable, we need to get a relationship. How P and V are connected? For an isothermal process, PV is equal to nRT. This whole part is a constant because process takes place at constant temperature. So you can put this value of P. P is equal to what? nRT by V dV is equal to nRT integration of 1 by V dV. 2 minutes to try. Complete. 2 minutes to try. What next? What next? Yes. When you write work is equal to nRT, Say third step. Work is equal to nRT. Integration of 1 by V. Log of V to the base E. This is termed as natural log. Limits. Volume varies from this point to this point. What was the volume? Original volume V1. Final volume V2. So volume varies from V1 to V2. You can put these limits here also. V1 to V2. So what you get is nRT log of final volume minus log of initial volume. This is how you put limits. Upper limit minus lower limit. Now the next formula, log of A minus log of B. Yes. Log of A by B. Log of A minus log of B is log of A by B. So what you get is nRT log of V2 by V1. So work done in isothermal process is this one. We can change it to the base 10 also. Refer to the book and come out with the answer that in case you want to write this as a log of to the base 10, then what? How to change this value to the base 10? Yes. Refer. You have already covered in chemistry. Refer to the book. Page number is 8 by 9. If you want to change it to the base 10, then what? Yes. What is the factor? 2.3. nRT 2.3. So it is 2.3 nRT log of V2 by V1 in case it is to the base 10. So this is one answer. This is also the same, but the change is here it is to the base E and here it is to the base 10. This value will be given to you. Log of this to the base E is what? Given by the examiner. Nothing to worry about. 1 minute to complete. 1 minute to complete. This was a small volume, small area, total area. Integration means the total area. So work done in isothermal process is area under which graph? PV graph. Any adiabatic process, any process, if you have a PV graph, work done is area under PV graph. Means what? Integration. Refer to numerical number 3. Numerical number 3. Which is based on work done in isothermal process. Numerical number 3 is 1 gram mole of an ideal gas at NTP is first expanded isothermally, underline isothermally, to twice its original volume. It is written compressed, it is heated, change compressed, correction is required. It is then heated at constant volume till its pressure is raised to original value. Calculate the total amount of work done. Given R is equal to 8.3 joule per mole per Kelvin. First draw process diagram. First draw PV diagram. Draw PV diagram for the process. Let's see how many of you understand the problem, not the solution. Draw PV graph. Process. First step is what? Expanded isothermally to twice its volume, then heated at constant volume till pressure raised to original value. PV. So always focus on this part. You take some gas, original volume V1, say it is equal to V naught. This is the original position 1. You heat it. How? Isothermally. Expansion will take place and the process is, yes, isothermal process, such that this final volume is how many times? Yes, final volume of V2 is 2 times V naught, original value. This volume of V1, this volume of V2, volume of V2 is 2 times V naught. Then what? What next? Heated at constant volume. Then you lock it. And you further supply heat. This process is what? Volume remains constant. Piston won't move outward. If you are supplying a heat, its temperature will increase, pressure will also increase. How do you draw this? Yes, constant volume. Volume remains constant till you reach a stage, till it reaches the stage where pressure is same as that of original pressure. So this is 1 to 2, 2 to 3. What you have to find out is work done. Total work done in the process is equal to work done in 1 to 2 plus work done in 2 to 3. Work done in 1 to 2, anyone? Formula? Yes, area under the graph, or this is nRT log of V2 by V1 to the base E plus 2 to 3. Yes, anyone? What is the work done? 2 to 3, what is the work done? 0, because piston doesn't move. Area under this graph 0, it moves from 2 to 3. So work done in 2 to 3, which is isochoric process, is 0. What is the value of N? Yes, 1 gram mole. N is 1 mole. R given how much? 8.3. Temperature, yes, at what temperature? Yes, NTP, underline NTP. Yes, 273 log V2 final volume 2 V naught, original volume V naught to the base E. So it is 8.3 into 273 into log of 2 to the base E. Calculate. I will give you the value for log of 2 to the base e, 0.69. This value is 0.69. 8.3, 273. This value is 0.69. Answer is 1.57 into 10 raised to the power 3.